I have a video for you today on factoring some interesting factoring type questions. Some of the ones that are a little bit more tricky or have little twists to them. Uh, if you've learned some of the little tricks that go with it, it makes your factoring a lot easier to accomplish. So if I look at the first example here, I'm noticing that I have two brackets that look almost the same. I have a 5x minus 1, and here I have a 1 minus 5x. They look the same, except the second one is in the opposite order of the first one. So I have a positive 1 instead of a minus 1, and I have a minus 5x instead of a positive 5x. So what I am thinking in terms of that, if I were to common factor a negative out of that, that would leave me with a negative 1 and then a plus 5x, which then makes that the same as the very first bracket. So if I pull that negative out and it attaches to here by multiplication, a negative times a negative makes that a positive. So in a sense, what I have here is my 3x times my 5x take away 1, but then I'm going to have a plus 2, so I'm switching that sign, and then I can rewrite this in the opposite order of 5x take away 1. Now those brackets are exactly the same, and I can common factor the 5x take away 1 out of those two terms. So the 5x take away 1 comes out, and in my other bracket I would be left with the 3x and the plus 2. So the other bracket has a 3x and a plus 2. So anytime you see two brackets that look almost the same except they're in the wrong order or the signs are the opposites, common factor negative 1 out, which will in a sense change that sign to the opposite, and then you can do your common factoring based on that. Okay, part B, I'm noticing I have two terms with a subtract in between. I can actually take the square root of both these numbers, so this is a difference of squares. If I square root x to the 4, we get x squared, so that goes in the beginning of my two brackets, my two binomials. The square root of 81 would be a 9, and one will be a minus and one will be a plus. They're conjugates of each other when you factor those. Now, the thing with this is we can go a step further. This x plus 9 is not a difference of squares, and in fact, when you have a plus in between and two perfect squares, that will never factor any further. But if I look at this one, I have an x squared, perfect square, minus, difference, and another perfect square of 9. That will factor further. So the x squared take away 9, square root the first, square root the last, make one a plus, make one a minus. Oops, I forgot to actually square root 9. I didn't square root it, I put just 9. Let me fix that. There we go. The magic of technology. That should be a 3. X plus 3, x minus 3, and then that still has to multiply the x squared plus 9. Okay, the next example is another quirky one. I have four terms, and quite often with four terms, we try to factor by pairing up terms. So I could look at pairing these two together, and they have m in common, but in terms of these two, they have nothing in common, and if I take the m out, I would get an m plus 2 in my bracket, plus 1, 1 minus n squared, and I don't have the same thing happening. So that particular grouping does not work, and no matter which two I try to put together, I will not get the same brackets so that I could common factor. But what I'm noticing instead, I'm going to group it as a 3 and a 1. So I'm going to put these three here together, and I'm going to leave this minus n squared by itself. Now I'm noticing that I have a takeaway and a perfect square. I'm thinking that maybe I can factor the beginning part here as a perfect square, and what that would allow me to do, what that will allow me to do is factor this as a perfect square, as a difference of squares. All right, so I've got an m squared plus 2m plus 1. So if I square root the first, I get m, square root the plus 1, I get 1, and take the sign from the middle, all to the exponent of 2. And then I check it. If I take the product of m and plus 1, I get 1m, and if I double it, I get my middle term. So this is factored correctly. So now what I have is a nice difference of squares. Okay, so if I have an m plus 1 all to the exponent of 2, when I square root that, I'm going to get m plus 1. So that goes at the beginnings of my brackets. I don't have to have that other set of brackets in here, but I'm just putting it in to show you what's going on. So the square root of n plus 1 squared is n plus 1. It goes at the beginning. The square root of n squared will just be an n. It goes at the ends, and make 1 a plus, make 1 a minus. Now I'll tidy that up a little bit more. We're going to have m plus 1 plus n, or m plus n plus 1, and here we have m plus 1, take away n, and that's its factored form. As I said, you might see the variables first and then the plus 1s on the end. You might see it like this as a solution, as an answer in the back of the book if you're doing these, but, oops, that should be an n. But either way is perfectly fine with me. Okay, looking at example D here, again, I have a subtract, and then I have something that I can square root and something I can square root. So I'm thinking this is a difference of squares. So I'm going to set that up again. I'm going to put 2 brackets, square root the first, we get 4x. It goes at the beginning of my bracket. If I square root the last, the square root of 16 is a 4, and the square root of x take away 2 all squared would just be x take away 2. Ooh, I just see something that I didn't do, and I'm going to go back and fix that. Okay, so one could be a plus, one could be a minus. Now, the reason I just saw something is I have a 4 here and a 4 here. I did not do the thing I say always, always, always check for first, and that's common factoring. So I'm actually going to erase this and go back and common factor because it will make my process a little bit simpler. Come on, eraser. There we go. It'll make my process a little bit simpler in the end here. So let's go back and do our common factor first. Okay, so 4 is our common factor. That leaves me with an x squared minus, and then if I take 4 out of 16, I get 4. And then I still have my x minus 2 all squared. Okay, now I'm going to go back, and so the 4 just gets copied down as we have it out front. And now I'm going to treat that inner bracket as a difference of squares. I'm going to have an x for the first term, and then the square root of this would be a 2x minus 2, and then I'm going to have another bracket of x, so I can make 1 a plus, and then minus 2 bracket x minus 2. Close that bracket, close that bracket. Okay, so what I get here then is I'm going to simplify inside the bracket here. I have an x plus 2, which multiplies through that little bracket. So that's going to give me a plus 2x and a minus 4. And my other one is going to be x take away 2x plus 4. Okay, so that leaves me with 4 bracket. X plus 2x would be 3x's minus 4. And the other one, x take away 2x, would be a minus x. I'm going to put my positive 4 first and then my minus x. But you could have minus x and then plus 4 and that would work. Okay, moving on to the last 2 examples here. All right, so the 3 terms here reminds me of my trinomial. It looks like a tricky trinomial. I am noticing these are all even numbers. I'm going to common factor first. I think my biggest common factor would be a 2, and it leaves me with 3x to the 4 minus 10x squared minus 8. Okay, now this inside the bracket still reminds me of a trinomial. It really has that form of ax squared plus bx plus c. It's just instead of ax squared, I have ax to the 4, and instead of just a bx, I have bx squared. So it still follows that trinomial pattern. We're going to have an adds to negative 10 and multiplies to negative 24. And I think, what will do that? 12 and 2, a negative 12 and a positive 2 will multiply to negative 24 and add to negative 10. Okay, so I'm going to decompose the middle term. So I still have my 3x to the 4. I'm going to have a minus 12x squared and then a plus 2x squared and a minus 8. And then from here, I'm going to group for a common factor, so I'm going to do 2 and 2. I have a 3x squared that's common to the first, and that leaves me with an x squared minus 4. And then out of the second pair, I've got a 2 that's common, leaves me with an x squared minus 4. Now what we have, x squared minus 4 is common. I'm just going to use a round bracket. It's common, x squared minus 4, and then we're left with a 3x squared plus 2, and we're not done. And the reason we're not done is because I'm noticing we still have a difference of squares here. So now I'm going to factor that as an x minus 2x plus 2. And now we're fully factored. That's pretty cool. All right, last example here. I'm looking at my 3 terms. I'm noticing I have an m squared minus 9, an m squared minus 9, and an m squared minus 9. So m squared minus 9 is common to all 3. And I hope I can fit this in here. And what I'm left with then is, in my other bracket, an x squared minus 7x and a plus 12. I really should put my phone on silent, shouldn't I? This is what snow days do. I'm getting some texts to communicate what's going on here. There we are. All right, now inside each of those brackets I have some more factoring. The first one, difference of squares, m minus 3, m plus 3. And then my second one is a simple trinomial. 2 numbers that add to negative 7 and multiply to positive 12 would be 3 and 4. So m minus 3 and m minus 4. Because it's a simple trinomial, you can go directly to the answer. Now you might see that written as, since there's 2 factors of n minus 3, you might see that written as m minus 3 all to the exponent of 2 times m plus 3 times m, take away 4. And we're done.